I am a full stack software engineer at Ambient. We are based out of Calgary with a team in Houston as well. We have a very buzzword compatible name. When in reality what we do is a lot of think self-driving cars for oil wells is what we do right now. We are hiring, so if you're looking to work remotely at an exciting place, exciting technology, we use a lot of JavaScript. We do not use Pony, so don't worry. And but if you're ever interested, feel free to reach out to me, call me, talk to me after. I was the last week in Pony maintainer, so I maintained a newsletter for Pony for a long time until I just had another child, and I retired from that because I have been busy. So what am I not? This is also very important. I am not a Pony expert, I don't think. I've been working with the core team for a few years. I know Pony, I can write Pony, and I've worked with it a lot, but I am not a Pony expert. I won't be able to answer your questions about how it's implemented in the back end. I am not good at making presentation slides. As you can, I picked the second Google slide template instead of the first one, so maybe it'd be different, but then I found out the guy going after me picked the second one too, so. Don't worry, and I'm not good at a lot of other things. So I guess to get started, this is kind of if anyone asks what is Pony, this is the broad generalization of what it is. It's an open sourced, object-oriented, actor model, capability secure, high performance programming language. It has a very verbose description of what it is. Open sources we do develop, we accept pull requests, you can go on there, look at our code. It's on GitHub. Pony C is the name of the Pony compiler that we use. We do have some other projects like Pony Stable, which is our attempt to name it something clever that had to do with horses. But that is a package manager that you can use along with the compiler if you want to work in your program and stuff like that. Actor model, I don't know if anyone has worked with Erlang, Elixir, Akka, anything along those lines. It's similar, but it's not quite the same actor model that you'd be used to if you're coming from Erlang or something like that. But we'll get into that kind of that's what helps and allows for the safe usage in concurrent programs. It is capability secure, which not a lot of people probably have experience with. When I came and started working with Pony, this was by far the biggest stumbling block because I'd never heard of it before, never used it. It was something that these reference capabilities, which I'll talk about, was something that was totally new. So in high performance, it does compile down to machine code. It is fast, and it does have a foreign function interface to C. So on the talk, I forgot who said it this morning, but I can't teach you Pony in 30 minutes. I hope to tell you what makes me excited about Pony, and I wanted to kind of talk about the two big kind of the pain points that you get when you're learning Pony. That's going to be reference capabilities and kind of how the actor model works in that and guaranteeing data safety and concurrency. So first things, concurrency is hard. I don't know if anyone has wrote concurrent programs. If you have, they suck. If not, take my word for it. It's not fun. Mutable state is a disaster to work with. You cannot share it safely. If you've ever worked with threads, either in Java or across any other any thread-based language, they are confusing, they can be hard to implement, they have a high overhead cost, they can lead to bugs that are hard to track down, and anytime you're using anything like locks or you're using anything like that to guarantee safety and thread safety, you're gonna get a big performance hit. And so it's, anytime that you find something that can make this any easier, it's very exciting, and for me that's kind of what Pony was, is it makes a lot of the difficulties that you have when you're writing a concurrent program a lot easier and safer. And as I'll talk about, it lets the compiler do a lot of the hard thinking for you. And then I think it was the Reason talk where he said if it compile it works, and that's kind of the same thing that Pony is. So how can we help? It is type safe, like super type safe. There's a mathematical proof. It was developed by Sylvan Klepp. She was working for Microsoft Research in Cambridge, and so there's a whole proof that goes into how type safe it is. I didn't read it. You can trust me. I trust them, so if they're lying, then they're in trouble. It's memory safe, exception safe. There's gonna be no data races, no deadlocks because you don't have any locks. It compiles to native code, and it gives you the actor model to help you model concurrency and allow you to not worry so much about the things that you typically would worry about with a concurrent program. All right, so it all sounds great, and it's like a huge, big pitch, but it's a lot to deliver on. So I picked out, there's a lot of stuff that goes into Pony. There's a lot that goes on, and I just wanted to pick out the two things that I think are the biggest stumbling block when looking at Pony and trying to learn Pony. One is the actor model. So in other languages like Erlang or Akka, I would say that the actor is looked at as a unit of concurrency, where in Pony it's more so a unit of sequentiality. I think that's the word. But so actors are single-threaded, which means that they're going to run their code sequentially from top to bottom. Within a single actor, you don't have to worry about data updates, because as we'll talk about reference capabilities, it's going to give you permissions and abilities and what you can and cannot do with data as you pass it between actors. So in an actor model, if you're not familiar with it, there's a lot of message passing, asynchronous message passing, that you tell someone to do it and you don't get an immediate response, and then they allow them to work on it. So the only problems are when you want to share data between actors. So because it is single-threaded in Pony, you don't have to worry about it as it's sequentially going through, and there's behaviors and functions we'll talk about. You don't have to worry that within there you're going to have any problems. So then you get into the issue of, okay, great, but I'm not going to have one big actor as my entire program. I need to send data, I need to share data, I need to share different data structures, I need to be able to do stuff. And so reference capabilities are what give and allow permissions. And this was like something that was like a foreign language to me. So hopefully I can help explain it a little bit, and maybe just enough where you'll get into exploring it, want to learn more about it. Feel free to ask me any questions. Amongst the community, we have found that this is by far like the biggest kind of stumbling block for people learning Pony. So reference capabilities, why they're important to us and why we have them. It allows us to share immutable data and exchange only isolated data. Because isolated data is, if it's isolated, you're not worried about it. And if it's immutable, you can also share it, but then you get into we'll talk about some of the other reference capabilities, but then you get, okay, if it's updated, how does everyone else know it's updated? So that's kind of you get in a little issue with that. This is the one I like. It allows the compiler to save your butt and keep you safe. If you, anywhere in your program, once you run the Pony C, the Pony compiler, if you are handling any sort of unsafe data, or if you are, it just won't compile, and it will let you know why it's not working, what you can do. It can give you some kind of tips. And that is, I've worked in a lot of languages, and I know in Java, I never felt safe with concurrent code, ever, even though I should have, but I didn't. And now I know that whenever I run it and compile it, I feel safe with Pony code. And then because of this, we can have safe concurrent programs without locks. Now this is where you're supposed to applaud, but not a lot of people have worked with concurrent programming. But if you did, you would applaud here, because it's very impressive. Oh, thank you. So if you had worked with concurrent programming, that's a big deal, because they are the worst. Okay, yeah?
So how do actors show data?
I'm glad you asked. Yes, we're going to get into it. So like I said, a lot of message passing is the only way. I'm glad you asked about the actor model. So let's talk about the actors in Pony and how they communicate with each other. So they are single-threaded, like I mentioned, so you never have to worry about running out of order. They're just going to run top to bottom. And so you don't have to worry about data updates. And when you're worrying about concurrent programs and all this stuff, data updates are what gets you in trouble, because knowing that something is updated, whether or not it's been updated, can cause a lot of problems. So it is object-oriented Pony, so actors are similar to classes in that kind of construct, if you're familiar with classes in traditional object-oriented programming. The only difference is, and this is where the communication with the actors comes in, is that actors have what are called behaviors and instead of functions. Well, you can have both, but they have behaviors. So behaviors are run asynchronously. So what you do if you need to communicate with an actor is you would pass it a message, say, hey, I need you to do this, or whatever it may be, and it's going to return it's a none. So no matter what you pass to it, it's always going to return none, because it is not going to always, if you run a function, it's going to execute at that moment. With behaviors and the asynchronicity of it, it's going to run at some non-determined time that you don't have to worry about. So you can handle that. I'll show you an example at the end with, you can handle that with promises, or there's a lot of different constructs where you can handle that. But you're basically just telling the actor, hey, do this, and then thank you. And you're just letting the actor kind of handle that concurrency. So they're like functions, except the functions are synchronous while behaviors are asynchronous. They communicate each other via message passing, similar to how you would in Erlang or I believe Akka. And so there is a Pony scheduler built into the Pony runtime, and this is what it's going to do is it takes and looks at how many cores you have on your computer, and it will assign as many, like let's say you have 8 cores, it'll run out 8 and run 8 behaviors at all times or whatever the scheduler determines, so that it doesn't have, so you can run them all at the same time because you're not worried about, is this looking at this data, is that sharing the same data as this, has this updated yet? Because it's all asynchronous, you don't have to worry about that. And they're sequential, so only one behavior at a time, like I talked about, will stop down, and they're very cheap, which locks are not, threads are not. To create an actor in Pony versus a class, it's only 256 bytes more memory. So if you're working with, that's huge when you're dealing with something. It's a very small, minor difference. So the actor model is pretty, not too hard to get wrapped around. It's like, it makes sense. Reference capabilities, on the other hand, are difficult. So working on the idea that there's these 2 laws of shared references, right? So whenever you're sharing references to data within a program, there's the read law, the write law. So you write only when you know no one else can read or write. That way it's safe, you don't run into any problems. And the write law is read only when you know no one else can write. So it's simple to think about, but getting a program and compiler to enforce this takes a lot of work. And that's where reference capabilities come in handy. And so as you can see, we want to adhere to this so we can have safely share data. We can pass, because we do have to pass it from actor to actor. We have to somehow communicate and share data with each other. So it allows you to use that Pony type system to guarantee that you're handling the data safe. So not only are you getting type guarantees when you are compiling your program, you also know that you're safely handling all the data. You don't have to worry about it. And if I made this up, and it's pretty good, I think. If it ain't safe, it ain't compiling. I came up with that last night. And and it allows massive trust in the compiler and the type system, which I feel like if you have a type system, and that's why you have it, I want to be able to trust it. And the fact that I can trust it with not only type safety, but also that I can, concurrently and data handling wise, I can trust and know that it's going to be okay is huge. And so as we're talking about communicating with actors, there's some, the next slide is going to try and talk about, there's 6 different reference capabilities. And I'll kind of go through them. But there's sendable references are the ones where you're communicating with other actors. So a lot of times when you send data, there's an ISO, val, and tag. So this is the verbose from the website that I will not read to you. I have an English translation coming up. But this isolated, which is an ISO in our language, value is a val. So reference, ref, box, transition, it's just TRN. And then there's tag. So there's 6 reference capabilities within the Pony type system. This is, at the end of the talk, I have a lot of references. But this is kind of, so if you've ever worked with, anytime you open up a file in Unix or Linux, you think of the idea of permissions, right? So you open up a file, and then you open up that file with a set of permissions. So you're either going to be able to read only, you'll be able to write only. Anything along those lines is you have some sort of capabilities that you can do to this file that you've opened. And if you think about it like that, it's kind of similar to how reference capabilities are handled in Pony. So ISO is when you have the only reference to a mutable data structure. So if we remember back to the beginning, the problem is hard with concurrency is dealing with mutable data structures. So if you want to deal and handle a mutable data source, you are the only one who can handle it. So it's an isolated reference. No one else is going to have access to it at that time. No one else, you can handle it and work with it safely and not have to worry about, okay, is this going to get updated from over here? I mean, it's a huge relief. And so you can, if there are some other capabilities that go beyond this talk, but you can recover and consume capabilities because at some point we don't always want that isolated reference. At some point we want to be able to give that up, like work on it and then give it up to send it to another actor. At that point you can consume reference capability, but I didn't get into that. So feel free to find me after, and I'll be happy to talk about it. Val, so anyone can read, no one can write. What you typically would think about when you think of an immutable data structure. Anytime you see val, it's pretty much, you can also be safe because it adheres to that rules prior, is that as long as no one can write to it, you don't have to worry about it. It's not going to be changed, not going to be updated. So as long as you have that val reference, it can be shared safely among actors. Ref is only, so this falls into like kind of the local reference capability. So it is only within an actor can you have a ref. You can't send it. It's not a sendable reference. So it's just like your traditional reference to a mutable data structure. So as you used to using in other languages. Box is another one that is not a sendable, but is local readable. You can read it locally, but you can't write to it. And then transition is also, it's another one you can't send. So you can only one writable reference, but you can have as many other people reading from it as you want, which if you handle that within an actor, you're okay. And then tag, it denies everything, which seems stupid, like you don't need it at all because it doesn't matter, but it allows you to identify things as you send them between actors. So tag is simply, you're just tagging this with this.
Josh, are you talking about passing pointers between actors?
Not pointers, so references to. So it's similar, but they're not actual pointers.
So, I mean, I'm trying to understand, because like in Erlang,
Yeah.
they deep copy all the data and pass it over. You're not talking about copying the data, you're talking
No.
about passing, references to the data.
Correct.
Gotcha, okay,
Yeah.
thank you.
Thanks for asking. Yeah, that helps clear it up. No, it's not like Erlang. So this is a reference capability matrix. So these are the ones that we've talked about. These are kind of, you can see in the top here, these are ones that deny global access. So these don't deny any, which is a tag, and it also doesn't deny any local aliases. So that's going to be your tag because it doesn't allow you to do anything with it. Deny, and then if you look at like val and box, it's going to deny global right aliases, but it doesn't deny local, and then val does not deny local. So this is a lot of information that can be overwhelming at first, and it's definitely different than anything that I had ever worked with before. So if it's totally overwhelming, don't worry. It takes a lot of time, and I'm still learning it myself. So what it does is it allows you to not have to worry about that safety of kind of what is accessing my data, what's not accessing my data, and there's a lot more to learn and teach than I have in. Oh yeah, my time's come. Okay. Anyways, we'll move on. So Pony sounds awesome. Of course, it's great. There's a lot of pluses to it. There's also many reasons not to use Pony. I think we are on like 0.28 right now, version 0.28, so there's a lot of breaking changes. It is not, the API can change at any time. So that is something it is being used in production by Wallaroo Labs out in New York. They do big data processing, and a lot of the core team works for them. And so it is used in production, and it's used in production safely. But that is something to keep in mind if you're ever thinking about, no one even lets me put it in production, so it doesn't really matter, but it's one thing to think about. It also allowed me to use my favorite movie, Batteries Not Included picture, because nothing is included. If you want it, you're going to write it. It's not like other languages right now where you can go and find a package. There's some, but most of the time, if there's anything that you're looking for that you want to be able to do with Pony, you're going to be the one to write it, which can be terrible and or very exciting because you'll be able to write that package and have it used by the community, and the community is very helpful and will help you get it. But there's not a lot that's just out there to grab. Tooling editing support. There's some syntax highlighting, and that's about it. Someone's working right now on a language server for it, which will be nice because then we can port it to all different editors, and then we'll be able to, you'll get that nice kind of rich editor experience you have in other languages. And if you're not writing highly concurrent code, you probably don't want Pony. It's exceedingly great at what it does, but I wouldn't, like, if I was just writing a simple web server, I would not use Pony because it's going to give you, it's just not the right kind of domain use case for it, in my opinion. So Pony allows you to work safely in a concurrent programming environment. All right, so let's look at some code very quickly. So I just wanted to give you guys kind of an example of what Pony code actually looks like, because it's great talking about reference capabilities and all this stuff, but thought we'd take a look just at, it's a simple program. It's a kind of a account that has an account aggregate here. Can everyone see that?
Can you actually make it a little bit bigger, please?
Oh no, I think so. Is it bigger?
That's better.
Okay. So every Pony program has a main actor. So there's one entry point into the program, and that's going to be the main actor. So as you can see here, let me get, the BE here is a behavior like we talked about. So that is, you know, the asynchronous function like we talked about that only actors can have. And so everything you have to pass. This right here is an example of line 51. I don't know if you can see it. So there are promises that you can use as well when you're dealing with you know, actors that you're referencing to and you're waiting for data that you don't know when you're going to get it back. Since it's asynchronous, you can use that. And this is also a Lambda function that you would typically see in anonymous function or something like that you might be used to in other languages is used as well. So let me show you. So here is a traditional class. And this val right here, so this is how you would give a reference capability to a class or anything that you want to do. You just annotate it like, so everything in Pony has, there's a type and there's also a reference capability. A lot of times there are some given by default to everything. So you won't always have to annotate it with whatever the reference capability is, but so this is saying that this is a val class, a val reference capability on account summary. There's some fields up here, and then new create is, so create is similar to how you would think of a constructor in Java or anything else like that. It's called implicitly whenever you create a new object. And then there's a couple just functions there that will return. Anything with a leading underscore like this is private. So if you need to make anything private to a class or to an actor, you just give it a leading underscore and it'll be private. And so this behavior right here, all it does is it takes a transaction event, which I'll show you where we send it, and then it updates the balance to be with that amount. And then, so let's see. So as you can look at, so every time we call this aggregate, which is that actor, and we call the handle transaction event, it's, this recover here is, so there's a lot to it, and I only have like a couple minutes left, so I can't explain too much of it, but I'll show you what it looks like when you run it. So if I run the compiler, what it's going to do is run through, these are all kind of built-in Pony collections. And as you can see, so it runs through, compiles it, links it, does all the, you don't have to worry about any of that kind of stuff, and gives you one binary, which will be the name of the folder that you're in. You can change that, but like if I just run Pony C, it's going to build and compile everything for me, and then I'm left with this binary that is the name of the Pony that I just compiled. If I run it, you'll see that it's going to log out the different transactions that I did within that. And I could put this up on GitHub too if anyone wants to look at it. Because it's a lot to digest, Pony. It's a lot different than a lot of things that when I was first learning it that I'd ever used before. So there was a lot to it. And so my presentation was incredible, and I've sold you on Pony. What do you do now? So we have a strong but small community. We have a Zulip chat, which is Slack alternative, arguably better. You can go to ponylang.zulipchat.com. Very helpful, very friendly. We'll answer all questions. You'll see that most people are there fighting with reference capabilities, so you'll be in good hands. The website is ponylang.io. All documentation is there. We have a tutorial. There's also Pony patterns where it kind of talks about some of the common patterns that you see in Pony programming. We also have an open collective where you can go if you want to support the Pony development. And that's it. Thank you.